Good day everyone, I'm Erica Cortez and welcome to KimikApp. In this video, we'll be discussing the concept of the mole in chemistry. We'll cover its history, definition, and significance, explore Avogadro's number, and look at some real-world examples to see how this essential unit helps chemists measure substances accurately. So let's get started! Let's start with a bit of history. The concept of the mole in chemistry is a key unit used to measure the amount of a substance. It was first introduced by Italian scientist Amedeo Avogadro in 1811. Avogadro's law stated that equal volumes of gases at the same temperature and pressure contain an equal number of molecules, which led to the idea of the mole. Later, the mole was defined as the amount of a substance that contains exactly 6.022 times 10 raised to the 23rd particles, such as atoms or molecules. This number is called Avogadro's number, and is based on the mass of 12 grams of pure carbon-12, which contains 1 mole of carbon atoms. The mole allows chemists to relate the mass of a substance to the number of particles it contains, making it essential for chemical calculations. Today, the mole is widely used in science to understand and perform chemical reaction, stoichiometry, and calculations involving substances. Now let's proceed to the definition and significance of mole in chemistry. In simple terms, a mole is a unit used in chemistry to count very small particles like atoms, molecules, or ions. Since these particles are too tiny to count individually, we use a mole to represent a large number of them, which is the 6.022 times 10 raised to the 23rd particles. And this number is called the Avogadro's number. The mole helps chemists connect what they see in the lab, such as grams, milliliters, to the tiny world of atoms and molecules. For example, knowing the mole of a substance helps in measuring how much of it is needed to react in an experiment. Next, let's explore Avogadro's number, which is a fundamental constant in chemistry. This number tells us the number of particles such as atoms, molecules, or ions in 1 mole of any substance. And as I've mentioned a lot of times earlier, this number is 6.022 times 10 raised to the 23rd. This means that in 1 mole of any substance, there are 6.022 times 10 raised to the 23rd particles. It's a huge number because particles like atoms and molecules are incredibly small. Now, why do we use Avogadro's number? Since we can't count individual atoms or molecules as they are far too tiny and numerous, Avogadro's numbers allows us to group them in a manageable way, which is by moles. This grouping helps us move between the microscopic world of atoms and molecules to the macroscopic world, which we can see and measure. Avogadro's number represents the number of particles in 1 mole of a substance, which is approximately 6.022 times 10 raised to the 23rd particles. Thus, 1 mole of any substance contains 6.022 times 10 raised to the 23rd of its representative particles, whether they are atoms, molecules, or formula units. For instance, 1 mole of carbon-12 contains 6.022 times 10 raised to the 23rd carbon atoms. 1 mole of ethanol contains 6.022 times 10 raised to the 23rd ethanol molecules. And 1 mole of sodium bicarbonate, which is baking soda, contains 6.022 times 10 raised to the 23rd formula units of sodium bicarbonate. To grasp the scale of Avogadro's number, imagine this. If you had 6.022 times 10 raised to the 23rd grains of sand, they would cover the surface of the Earth to a depth of about 15 meters. Or if you had 6.022 times 10 raised to the 23rd feathers, they would be enough to fill a balloon the size of the moon. Interesting, right? Now, let's discuss converting particles to moles. To convert the number of particles such as an atom or molecules into moles, we use the following formula. Moles is equal number of particles divided by to the 6.022 times 10 raised to the 23rd. This formula allows us to simplify extremely large number of particles into something more usable, which is the moles. And to bring the mole concept to life, let's look at some everyday example of moles. In chemistry, we use the concept of moles to count large numbers of tiny particles like atoms or molecules, as I've mentioned a lot of times. To make this concept more understandable, let's look at how many moles are present in some common everyday substances. First is the water. For example, a glass of water which has about 180 grams. And how many moles? The molar mass of water is 18 grams per mole. If you have 180 grams of water, you can divide it by the molar mass. So we have moles of water is equals to 180 grams divided by 8 to 18 grams per mole, which is the molar mass. Then we have moles of water, which is equivalent to 10 moles. In conclusion, there is 10 moles of water in a glass of water. Next, for a table salt, a small shaker has about 58.5 grams of salt. And how many moles again? The molar mass of table salt, which is sodium chloride, is 58.5 grams per mole. If you have 58.5 grams of salt, then we have moles of salt is equal to 58.5 grams divided by it to the molar mass, which is 58.5 grams per mole. Then we have moles of salt is equivalent to 1 mole. Therefore, there is 1 mole of salt in a small shaker. And lastly, glucose, which is commonly known as sugar. A sugar cube has about 10 grams of glucose. And how many moles? The molar mass of glucose is 180 grams per mole. And if you have a 10-gram sugar cube, we have moles of glucose is equivalent to 10 grams divided by it to the molar mass, which is 180 grams per mole. Then we have moles of glucose is equals to 0.056 moles.
Therefore, a sugar cube contains about 0.056 moles of glucose.
So there you have it. The mole, an essential concept that connects measurable amounts of substances to the atomic scale. This connection is what makes chemistry precise and powerful. Thanks for watching! And if you enjoyed this video, don't forget to like, subscribe, and keep exploring the wonders of chemistry here on KimikApp. Until next time!